This video is on the operations in scientific notation. So the essential question here is, how can you perform operations with numbers that are written in scientific notation? Well, when you're finding the sum or difference, you need to write your answer in scientific notation. So what you're going to do first is you're going to kind of use the distributive property here. They both have 10 to the 3 in them, so we're going to take that times 10 to the 3 out, and you're left with 4.6 plus 8.72. If you remember, this is kind of just like we done earlier. We've got our same factors right here, and then you rewrite what's left. Now all you have to do is add up the numbers that are right there in the parentheses. 4.6 plus 8.72 is 13.32 times 10 to the third. Now you can't stop there, because the directions here ask you to write it in scientific notation. When you write something in scientific notation, remember there is only one number to the left of the decimal. And if you're looking right here, we've got two numbers, the 1 and the 3. So we've got to move that decimal over and rewrite it in scientific notation. So it'll be 1.332 times, well, we took a 10 to the first out, times 10 to the third. So now if we add those exponents, we get 10 to the fourth now. So it would be 1.332 times 10 to the fourth. So let's look now what happens when we're doing subtraction. Again, you're just going to rewrite it so that they both have the same times 10 factor, so we can factor that out. So we're going to rewrite 6.6 times 10 to the negative third. So it has the same power as our other one. So it's going to be 6.6 times 10 to the negative 1 times 10 to the negative 2, or you could just write 0.66 times 10 to the negative 2. Now you just need to subtract your factors. Take your 3.5 times 10 to the negative 2 minus 0.66 times 10 to the negative 2. So by just subtracting our factors, we've got 3.5 minus 0.66, which is going to be 2.84 times 10 to the negative 2. Now here we don't have to rewrite it because it is in scientific notation, because there is only one number to the left of the decimal. In standard form, remember, we move our decimal over 2, so we'd actually have see if I can write a 0.0284 in standard form if we were to write it in standard form. So let's look at this next problem. How about, what do you do when you are multiplying and you want to write your answer in scientific notation? Make sure you pay attention to that. Still want scientific notation. Well, the thing about multiplication is you've got the commutative and associative properties of multiplication. With that being said, you can rearrange the order in which numbers are multiplied. If you take 2 times 3 times 1, you get 6. But if you take 1 times 3 times 2, you still get 6. It doesn't matter what order. And the associative property is just regrouping them. You don't have to write those words over there. Just write down our math that we're doing right here. So we've got 3 times 5, and then times 10 to the negative 5th times 10 to the negative 2nd. Well, we know how to do all that. 3 times 5 is 15. And remember, whenever we have exponents with the same base, in this case the base is 10, you can add the exponents. Negative 5 plus a negative 2 is going to give us a negative 7. So 15 times 10 to the negative 7th. But remember, we were asked to write it in scientific notation. Again, that's not scientific notation because there's two numbers before on the left side of the decimal. So now what you're going to want to do is move that over 1. So you're going to have 1.5. We moved it over 1, which is times 10 to the first. And we still have our times 10 to the negative 7th. But we still need to simplify. So you end up with 1.5 times 10, adding exponents, the 1 plus the negative 7 is going to give us negative 6. So you get 1.5 times 10 to the negative 6. So how can we use this? Well, And so, when you're talking about things that are in like space and everything, the distance is in far greater numbers than we really can comprehend and can really deal with. So that's why we use our scientific notation. But how many times greater is the diameter of the sun than the diameter of the earth? Well, let's see. The diameter of our earth is 1.28 times 10 to the 4th kilometers. The diameter of the sun is 1,400,000 kilometers. Well, it's kind of hard to judge those when they're written in different units like that. I mean, not the units are different, but the ones in standard form, ones in scientific notation. So, what we're going to do is we're going to write the diameter of the sun in scientific notation. So, remember, we want one number to the left of the decimal, so we're going to move it to go in between the 1 and 4. So, 1.4 times 10 to the, if you count it all out, we moved it 6 places. And it's positive because we were going to the left. It's a big number, it's a positive. So that's how it's written in scientific notation. So now we're going to divide the diameter of the sun by the diameter of the earth. That's how you find out how many times greater something is. What you would have to multiply the earth by in order to get the sun. So you're going to take the 1.4 times 10 to the 6th and divide 1.28 times 10 to the 4th. Well, we can just rewrite this by dividing them up as fractions. 1.4 divide 1.28 and 10 to the 6th divide 10 to the 4th. Because we know how to do all this. If we divide 1.4 by 1.28, you get 1.09375. Now we have to divide 10 to the 6th divided by 10 to the 4th. Now if you remember your rules here, if you are dividing numbers and they have the same base, all you have to do is subtract the exponents. So keep the base the same, subtract the exponents. So you're going to have 1.09375 times 10 to the 2nd. 6 minus 4 is 2. And then if you wanted to write that in standard form, it would be 109.375, because all we have to do is move the decimal point over 2 spots and get the 109.375. So the diameter of the sun is about 109 times greater than the diameter of the earth. Finish up the problems on your notes and make sure you show them to me, and then finish your assignment on Clever.